Welcome and good afternoon, everyone. Thank you for joining the first webinar in this year's Hurricane Awareness webinar series, where each week throughout the month of May, we will feature various topics as we prepare for the start of this year's hurricane season. My name is Alyssa Zabrowski, and I'm your host for today. I work with NOAA's Disaster Preparedness Program as the Southeast and Caribbean Regional Preparedness Coordinator. Our program's goal is to help NOAA staff and partners better prepare for, respond to, and recover from disasters. And as someone who works in this region, I am a member of NOAA's Southeast and Caribbean regional team, who is actually presenting this series. And facilitating this webinar, we have the regional coordinator for SECART, Catherine Egan. Catherine, do you want to go ahead and introduce yourself real quick?
Yeah, absolutely. Thanks so much, Alyssa. Hi, everybody. Like Alyssa said, I'm the Southeast and Caribbean Regional Coordinator, so I help co-lead the Southeast and Caribbean Regional Collaboration Team, or SECART. So SECART is one of 8 regional teams across the country working with both NOAA staff and partners throughout the United States to foster stronger collaborative ties and improve NOAA's regional capabilities and services. You can find more information on SECART by following the link that I'll put into the chat momentarily. All right, and with that, I'll pass it off to Lissa to present the rest of the webinar.
Thank you so much, Catherine. We will also put the link to SECART's webpage where you can register for the other upcoming webinars in this series, and I will mention that again at the end of this presentation. A few quick reminders before we get started. As you can see here on the screen, this webinar series will be recorded, and we are going to do our best to get it posted as quickly as possible after today, and it will be posted on SECART's YouTube page. Due to the large number of folks that we have joining the call today, some slides might get a little bit delayed. And finally, I am going to go ahead and introduce Robbie Berg, who we have presenting today. Let's see, let me stop sharing my screen. All right, so a little bit about Robbie while he gets his presentation loaded up. He is the Warning Coordination Meteorologist at NOAA's National Hurricane Center in Miami, Florida. As the Warning Coordination Meteorologist, Robbie provides impact-based decision support services to emergency managers, media, and other partners, both domestically and internationally during tropical weather events. He plans and coordinates the Hurricane Center's outreach and training activities and makes tropical cyclone forecasts during the hurricane season. And in addition, Robbie leads the NHC's efforts to infuse social science and risk communication concepts into hurricane forecasting, products and services, and outreach. And with that, Robbie, I will pass it over to you to get us started today.
Great. Hey, thanks, Alyssa, and thanks, Catherine, for the introduction. Welcome, everybody. I'm glad you could join us today. Seems strange that we're already getting close to hurricane season again. Feels like we just finished last hurricane season. We're still finalizing some of the things from last year and already looking forward to this coming year. So kind of what we're going to go over today is what are some of the lessons that we learned from last hurricane season? I'm sure everyone's aware it was a very impactful year, particularly for the United States and for some of our partners in the Caribbean, Central America, and Mexico. And then also look forward to what do we have coming up for this upcoming hurricane season in terms of new products and services from the Hurricane Center. So let's get right into it. First off, I'm going to start this talk with a plea. And I think this plea is that we need everybody's help here. We say this because during hurricane season, before hurricane season, we often see a lot of headlines out there about these kind of gee whiz things, as I like to call them. They're interesting little factoids about a storm. Sometimes it's things after the storm that just take time for us to understand and get a better sense of. And I'm saying we need your help because these little factoids often aren't really the main message that we want to be getting out there during a storm. So for example, talk about category 6 or highlighting the fact that a storm has been downgraded. These are actually things that take away from the main message of what's going on during a storm. And the reason I say that is because we're really worried about the fatalities, obviously, from these hurricanes, tropical storms, even tropical depressions. There is nothing in these pie charts that you're seeing here that says anything about headlines or downgrades or models. This is all about the hazards that unfortunately do take the lives of people that are affected by these storms. We've had two past studies that looked at fatalities in the United States from tropical cyclones, one from 1963 to 2012, and then a more recent one from 2013 to 2023. And you'll see that, I'll stress this a little bit later, is that storm surge and rainfall effects tend to be the biggest killers in tropical cyclones. Again, nothing to do with models, nothing to do with landfall. It's the hazards themselves that are causing so many problems. So again, focus on watches and warnings, focus on the risk of individual hazards, whether it be wind, storm surge, rainfall, flooding, tornadoes. All of that is what's really important, and what unfortunately does take the lives of people that are affected by these storms. So I want you to keep this in mind as we go through the lessons from this past year and think about how impactful have the hazards been from these storms. So let's get right into it. What did we learn from last year in 2024? I actually have 6 lessons that I came up with. I'm sure there's plenty more that we could discuss as well. Some of these are lessons that we already knew, but we were just kind of reminded again, based on the impactfulness of these storms, that there are things that we still have to learn about tropical cyclones, including hurricanes. So as a quick recap, just to kind of go over what did happen last year in the Atlantic from 2024, we actually had 18 named storms, 11 hurricanes, and 5 major hurricanes. And you can see there on the slide, the averages are 14, 7, and 3. So we were above normal when it came to the number of named storms, number of hurricanes, and major hurricanes. Last year was interesting because we generally started rather slow. And I think when we got toward later into June, into July, even parts of August, people are saying, where's the hurricane season? We've had a few storms, but it really wasn't this blockbuster season until we really got into late August and September, and then it just seemed like it was one storm after another. We actually had 10 hurricane landfalls across the region, 5 landfalls of hurricanes in the United States, and then another 5 in other countries, including Cuba, Grenada, Bermuda, and Mexico. The 5 U.S. hurricanes all occurred along the Gulf Coast. That actually ties for the second most on record for a given year. And unfortunately, I think the last stat there is the one that's most sobering, is that we had 425 total fatalities, 274 direct, 151 indirect, and 358 of those were in the United States. Those are large numbers, and those, in fact, take a look at Helene, for example. That was the deadliest hurricane to impact the United States, at least the continental United States, since Hurricane Katrina. So we know last year was impactful. We had a lot of significant storms across the United States and the Caribbean, and we did learn a few lessons from those storms. Not to kind of ignore the other side of the continent, but the Eastern Pacific, which is an area that we also cover, also had activity with some major impacts in Mexico. We had 13 named storms over there, 4 hurricanes, and 3 major hurricanes. That's about average. You can see the average numbers there are 15, 8, and 4. So about average on number of named storms, but actually below average on the number of hurricanes. We had 1 hurricane landfall. That was Hurricane John, which made landfall in Mexico as a major hurricane. And it was actually a prolific rainfall and flooding producer. We saw 31 direct fatalities on the west coast of Mexico, 29 of those from Hurricane John, and then 2 occurred from flooding from, at the time, was Tropical Depression 11E. In the post-analysis, we did go ahead and upgrade that to a tropical storm based on some of the data we received after the fact. But you can see there has nothing really much to do with wind, 31 direct fatalities, all from freshwater flooding. So let's go through some of these lessons. Lesson number 1, I've already kind of said it here, but water is still the main villain of this story. It's not wind. That's what many people think about with hurricanes is, what's the Saffir-Simpson category? And while that can be important, it's really water that remains the biggest player when it comes to taking people's lives from these storms. So I'll go back to the pie charts and kind of show you that again, is that if you look at these charts, both of them, and you take the storm surge, the rainfall, heavy surf or rip currents, marine impacts, kind of those 4 different hazards that are all water related, we've seen that water accounts for about 9 out of every 10 deaths that occurs in the United States from a tropical cyclone. So think about that again, 9 out of 10 deaths that occur from tropical cyclones in the US are due to water in some form. So I think that's a very important lesson to take away when we're thinking about these storms, is that it's not just due to the wind or the Saffir-Simpson category, but we really do need to be cognizant of the rainfall hazards that these storms bring. And those hazards have no or very little relationship to the strength of the storm. You can have a tropical depression which causes just as many, if not more, deaths than some hurricanes from the water hazards. So looking back at 2024, kind of here are some of the stats on water itself. Water was responsible for 59% of the direct deaths from tropical cyclones in the United States. That's a total of 127. It also accounted for 83% of the direct deaths from tropical cyclones in other countries across the region. So that would include the Caribbean and Central America and Mexico. The number there was 73. When we just look at the freshwater flooding component, so if you ignore the storm surge, rip currents, other marine incidents, and just look at freshwater flooding, that accounted for the most deaths. In Hurricane Helene, we had 95 direct fatalities from freshwater flooding, many of those occurring in the mountains of North Carolina. Hurricane John in the west coast of Mexico in the Acapulco region had 29 deaths due to freshwater flooding. So that, as you saw from the pie charts I showed, freshwater flooding continues to be one of the most impactful hazards when it comes to taking people's lives in these storms. In fact, of the 13 storms that caused direct deaths last year, 12 of those had at least one fatality attributed to freshwater flooding. So I think you're starting to see a pattern here that the water component is incredibly important, and we do need to be aware of what our risks are when it comes to what that water could do to us if we're affected by these storms. Even though water is one of the main impacts, I want to give some kudos out to our sister office up in College Park, Maryland, the Weather Prediction Center, in the rainfall forecast that they produced for Hurricane Helene in the southeast United States. So what you're looking at here on the left side is the rainfall forecast that WPC produced 3 days prior to Helene impacting the area. So it was issued at 5 a.m. on Wednesday, September 25th. On the right side is an analysis of what was observed after Helene hit the area. And I think what you can see is a remarkable similarity in the patterns of the rainfall that was produced across the southeast, across the Ohio and Tennessee valleys, and even capturing some of the peak or maximum rainfall totals across portions of northern Georgia, upstate South Carolina, and western North Carolina. So WPC did an excellent job in capturing the breadth of rainfall that would occur with this storm, and even some of the maximum totals that could possibly occur in portions of North Carolina and surrounding areas. If you look at the forecast, you'll notice there are some kind of dark to mid-range yellows in there, which is about 10 to 15 inches or higher of rainfall in those areas. And if you look at the observed, that's in fact what did happen. So it was clear that Helene was going to be a prolific rainfall producer, and especially if you have that much rain being dumped onto mountainous terrain, I think it was well known that some of those areas were going to see significant impacts from that type of rainfall. Those areas just cannot handle that amount of rain in a short period of time. And it's not just about the rain that occurred, but the impacts from the rain. So you have the flooding just from the water itself, but also being in a mountainous area, you get a lot of landslides and rock slides and debris flows that happened because of all of that water. This is a map that was provided by the United States Geological Survey, and every dot on that map is a location of a landslide occurring mostly in western North Carolina in the mountainous areas, with a few also occurring in the surrounding parts of South Carolina, Georgia, Tennessee, and then even farther north into Kentucky and Virginia. But even looking, say, just to the east and northeast of the Asheville, North Carolina area, a very high concentration of landslides that occurred due to the heavy rainfall that occurred over several days in that area. And I mentioned this was foreseen. I think we saw a couple days beforehand that rainfall was going to be the main player for Helene. Not that the other hazards weren't also important, but so much so that NOAA actually put out a press release, a rare press release to communicate the need for communities in those areas to prepare for catastrophic, life-threatening inland flooding, even well after landfall. And so as you can see there on the screen is a copy of that press release, even telling reporters that this is a rare news release. And so for NOAA to go the steps of actually releasing this before the storm hit, I think it spoke volumes to the fact that we knew, unfortunately, that something catastrophic was going to unfold, and we needed to get people in those areas aware of the situation and listening to their public officials, getting out of harm's way if they were able to. But I don't want to ignore the storm surge from Helene as well. So what happened in Western North Carolina, South Carolina, obviously was important, but there was also significant storm surge that occurred down along the west coast of Florida. And you can see there on the middle there is an image of the storm surge warnings that were up for Hurricane Helene. And on the right is an image of a forecast that was put out by the storm surge unit here at the Hurricane Center, forecasting peak totals of 15 to 20 feet above ground level. I'll note that the storm surge warning was actually issued 40 hours prior to the water levels rising along the coast, so it gave people enough time. If they hadn't evacuated yet, they could still have time to get out if they were in danger. As I said, more than 15 feet of storm surge above ground level was predicted for parts of the Florida Big Bend area. We know that's a particularly vulnerable area because it's like a catcher's mitt. The concave coastline just traps all that water, and that's why we see higher storm surge values there. Not to mention that's where landfall occurred. The Tampa Bay area actually received some record-breaking storm surge with as much as 7 feet of storm surge above ground level. And unfortunately, all of the storm surge fatalities that occurred from Helene occurred in Pinellas County, which, if you're not familiar with the geography, is there right along the coast on the west side of Tampa Bay. So even though we had higher storm surge values in the Big Bend area, all the fatalities occurred in the major metro area surrounding Tampa Bay, particularly in Pinellas County itself. So I think the lesson here is that you don't have to be right at landfall or where the eye crosses the coast to have the most impactful effects from storm surge. The storm surge from this storm extended well down the coast. Pretty much the entire west coast of Florida was affected in some way from storm surge. So I think that's a lesson to keep in mind. Both the water from rainfall and the water from storm surge does not have a direct linkage to exactly where landfall occurs. You can have a wide area that gets affected by these hazards, and I think that's something we have to keep in mind and keep watch of the hazards, the watches and warnings that are issued before the event unfolds. Okay, so that was lesson 1, talking mostly about water. Let's move on to a few others. Lesson number 2 is that yes, hurricanes can spawn significant tornadoes. I think there's been a long kind of break of time where we haven't seen a really high tornado producing system in quite a while. Hurricane Milton in particular was pretty prolific in its tornadoes. What you're seeing here is an image showing you the state of Florida, the Florida Peninsula, with the convective outlook that was issued by SPC, the Storm Prediction Center, and all of the tornado warnings that were issued by the local National Weather Service forecast offices. I think you can see there that SPC accurately predicted in their enhanced risk area in orange, where much of that tornadic activity would occur. And the WFOs were busy that day with all of those warnings being issued. In fact, it was 126 tornado warnings on that day for the tornadoes that Milton was producing. This is the second largest number for a single state on a single day, and it was only outmatched by Alabama during the super outbreak of 2011, where there were 134 in that state on that day. So the fact that a hurricane produced or caused 126 tornado warnings to be issued by the National Weather Service, it being the second highest on record for a state, is pretty remarkable. It's not something that we would tend to see for tropical cyclones. Here's a map showing where all of those tornadoes occurred. There were 45 known tornadoes, 1 tornadic waterspout on Lake Okeechobee. I think what's most remarkable is that 3 of those tornadoes were rated as EF3 tornadoes. And this is the first time in SPC's tropical cyclone database since 1995 for a hurricane to produce more than 1 EF3 tornado. So again, just a remarkable event in both the number of storms or tornadoes that are produced, but also the strength of some of those tornadoes. And unfortunately, we did see 6 fatalities due to those tornadoes as well. Just to show you some pictures of those tornadoes, and I have to thank some of my NHC colleagues for these two images. On the left side is NHC meteorologist Matt Onderlindy, who took this photo from western Broward County that day, and on the right side is from senior hurricane specialist Jack Bevan, who took a picture of that tornado or tornadic waterspout in Lake Okeechobee on that same day. So while we were busy at the Hurricane Center, a few people that had gotten off their shift or had worked overnight, they were still amped up to go out and see what kind of tornadoes that this storm was producing as it moved by to our north. This one here was a EF3 tornado near Lakeport, Florida. I don't know about you, when I saw this image, I thought this looks like it's from Oklahoma or Nebraska or Texas, just how ferocious this one looked. This is not something you typically see from many hurricanes. So again, Milton was a prolific tornado producer, a record producer, and I think it just goes to show that these storms can do that. And what's really interesting is that these tornadoes can often occur well ahead of the main part of the storm. So if you're still getting ready for the storm to hit, for the hurricane to hit, and you're having to contend with these tornadoes, that's just decreasing the amount of time where you can be out safely, getting your home ready, getting your family ready before the actual storm. So tornadoes can also be very impactful as one of the main hazards of a hurricane. Okay, lesson number 3 is that wind gusts matter. And I say that because if you look at here at this map of Hurricane Helene, this is showing you where all of the fatalities, direct fatalities, occurred from that hurricane. And you'll probably see a dichotomy of where those fatalities occurred based on the hazard. So first off, in western North Carolina, you can see a lot of these green diamonds. That was from freshwater flooding. But you also see a whole bunch of red stars. And these are all of the fatalities that occurred due to wind. So even though I've talked about how prolific or how dangerous water can be, Helene was a very significant wind producer. And unfortunately, we saw a lot of fatalities from that storm. In fact, if you take 4 of the hurricanes that made landfall this year, Beryl, Debbie, Helene, and Milton, we actually saw 79 wind fatalities in the United States from those 4 hurricanes. And that's the most in a single year since at least 1963. So again, we preach water, but there are also these events, these storms, where wind is also going to be important. It's not just a one hazard deal. As I mentioned too, the tornadoes, I'll just recap there, the 10 US tornadoes among those 4 hurricanes, that was the second most in one year behind 2004. Why was Helene such a prolific wind gust producer? Why did it produce so much wind damage so far inland? There's really 2 main reasons. One is because of how fast Helene was moving when it made landfall along the Florida Gulf Coast. And I'm showing you that here. This is an image from one of our hurricane specialists, Dr. Lisa Bucci. And what she's showing here is a histogram of all of the landfalls that occurred along the northern Gulf Coast, factored in based on their speed. In other words, how fast were they moving inland when they made landfall? And what you can see is that by the green dashed line and the red dashed line, that is the mean and median of that distribution. So most storms, on average, when they make landfall along the Gulf Coast, they're moving at about 10 to 14 miles per hour on average. Okay. What you see in that histogram is that Helene from last year was moving inland at 28 miles per hour. So that's more than double how fast most storms tend to move inland along the Gulf Coast. So what does that mean? Well, it's moving twice as fast as most storms, which means that storms don't decay much faster because they're moving faster. They're still going to take the same amount of time to weaken. So if you're moving a storm that much faster, twice as fast inland into the United States, it's going to be farther inland before those winds weaken. So that's exactly what we saw. So Helene remained a hurricane well up into Georgia. It remained a tropical storm well up into South Carolina, North Carolina. And it wasn't just the sustained winds, but it was the gusts that the hurricane was producing. In addition, it was moving into mountainous terrain. And we know as you get higher in elevation, you can see higher winds than you would see potentially at sea level. So the fast forward speed of Helene and the mountainous terrain combined to produce a lot of wind, even well inland, into some areas that don't typically experience that type of hazard. On the right is a map produced by John Cangelosi from the Hurricane Center, showing you wind gust observations color-coded by different ranges. Any of those red dots is essentially a hurricane force wind gust. And again, you can see that those red dots extended well up into Georgia, South Carolina, and western North Carolina. Some of the notable wind gusts were Mount Mitchell, which had a gust of 106 miles per hour, Banner Elk, 101 miles per hour, and then even into parts of central Georgia, including the Augusta area, a measured wind gust at the airport of 82 miles per hour, but the instrument did go offline for a bit. And some of the surveys that the Columbia office did suggested that there were winds as high as 80 to 100 miles per hour in that area. Here's some examples that were actually taken from the Columbia office of some of the tree damage in the Augusta area. So we have a lot of very tall pine trees in that area, and they were subjected to strong wind gusts for multiple hours as the core of Hurricane Helene went through that area. And so you get hurricane force wind gusts over, say, 2-3 hours, it's going to cause those trees to fail. They're just not used to experiencing that type of wind for that period of time. And so we saw a lot of tree damage in portions of inland Georgia and South Carolina, and even farther north into western North Carolina. These are some images showing you some of the mountaintops and the terrain, where not only did you have trees felled by the wind, but essentially defoliated. Those wind gusts stripped all of the leaves off the trees in some of those most exposed areas along the mountaintops from the wind. So Helene, gosh, you take that one storm and you look at the storm surge, you look at the inland flooding, and then you look at the wind even well inland. And it had its tornadoes as well, just like Milton did. It was an impactful storm in pretty much every hazard that we are tracking when it comes to these storms. Okay, lesson number 4 is that rapid intensification is and will likely continue to be a problem, but there's at least hope that we're getting better in forecasting these events. So taking a look at rapid intensification from last year. First off, I guess I should define that if you're not familiar what that means, but each case of rapid intensification is when a storm intensifies by at least 35 miles per hour over a 24-hour period. So we consider every 24-hour period as a separate case. In 2024, there were 34 cases of rapid intensification in the Atlantic. That included storms like Milton, like Beryl, like Kirk, as you see there on your screen. And that number, 34, is nearly double the mean number of RI cases for a typical year. The average from 2014 to 2023 was 18. And yet we had 34 separate cases of rapid intensification in the Atlantic this year. So that's pretty astounding to see that many cases of these storms strengthening that quickly. Now, I think Hurricane Milton took the mantle here, being the most prolific, quickly strengthening storm. It strengthened by 90 miles per hour over 24 hours from October 6th to 7th. The pressure in Milton dropped by 82 millibars in about 16 and a half hours, dropping to as low as an estimated 895 millibars when it was at its peak. So again, a pretty remarkable statistic there for Milton. Why is RI important? We have shown this image before, and it's to show you that a lot of these storms that go through RI, in fact, the ones that at least have affected the United States, the nation's strongest hurricanes, being 150 miles per hour or stronger, in the last 100 years were all tropical storms only 3 days before landfall. And you can see a list there on the left side of some of those storms. The average time to become a hurricane before landfall was 50 hours for those storms. So what that really means is that for most of the impactful storms that go through RI and affect the United States, we don't have 4 or 5 days, even 2 days in some cases, to watch a storm roll across the Atlantic and strengthen this way. A lot of these storms are storms that are forming and strengthening on our doorsteps. So across the Caribbean, across the Gulf, as the storm is heading toward the United States. So in essence here is that RI near land can mean shorter prep times in getting ready for these storms. So we can't always just look at, oh, it's just a tropical storm, I should be safe. We have to account for what the forecast is and whether or not the storm could potentially strengthen more than what's actually being forecast. But here's where the hope comes in, is that when we've gone back and looked at are forecasting a rapid intensification over, say, the past 15 years, we are noticing that we're getting better. There are encouraging trends that we're able to identify these cases where RI might occur. So what you're looking at here on your screen is a bar chart split into essentially 3 different 5-year periods. On the left is from 2010 to 2014. In the middle is 2015 to 2019. And on the right is 2020 to 2024. And in each of these 5-year periods, we're looking at what was our intensity forecast bias for these rapid intensification cases. So in other words, 15 years ago, or 10 to 15 years ago, when there was RI, we were forecasting storms by essentially being 26 knots or 30 miles per hour too low. So on average, if we were forecasting a storm, let's say, to become 100 knots or 100 miles per hour in 24 hours, on average, we were 30 miles per hour too low. The storm may have ended up being 130 miles per hour. Now what we're seeing over the past 5 years is that our intensity forecast bias has been trimmed to 16 knots or 18 miles per hour. Obviously still not perfect, but what it's showing is that we are essentially nudging back that intensity bias, and we're trimming it down little by little as we've been moving forward over the past 10 to 15 years. So again, by no means perfect, but it's showing progress in this arena in being able to forecast these events more frequently. And it's not even just people say, oh, the models are forecasting it better, so that's why you're able to capture these events. And that's partly true, but I also want to show that, the Hurricane Center forecasters are applying skill over the models. So I'll try and explain this chart. It's a little bit more busy and complicated than the other ones, but I'll just simplify it by saying on this chart, you want to be as far to the upper right portion as possible. So you want to be kind of in those purple shaded areas. And what that essentially means is that you have a high rate of detection, so you're able to detect cases of rapid intensification while also limiting your false alarms. So we don't want to cry wolf, right? So on this chart, the black dot is the official forecast issued by the hurricane specialists here at the Hurricane Center. All of the other colors, the blues, the greens, the oranges, the pinks, etc., those are the various models that we use to make the forecast, and they also would predict rapid intensification. But what you'll notice is that the black dot from NHC is deeper into the greens and blues than the models are. So what it means is that NHC's RI forecasts from last year have a higher, what's called a critical success index. So in this case, it's mostly driven by the fact that we are detecting rapid intensification more than the models themselves. Our false alarm ratio isn't much different from the models. Everyone's pretty much equal there. But in the rate of detection, NHC is able to predict that or detect that a little bit more frequently than the models we use to make the forecast. So I think there's some success there in that we are still providing skill over the models that we use to make the forecast. Okay, lesson number 5. Here, one of the key things we noted from last year is that storm formation can still be unexpected. 2 main cases here were Hurricane Oscar, which was a fairly small hurricane which formed north of Puerto Rico. It moved west toward the Turks and Caicos Islands, the southeastern Bahamas, and dove kind of to the southwest to the eastern coast of Cuba, as you can see there in the map in the upper right. The difficulty with Oscar is that the models did not really show much of a signal of Oscar's possibility of forming. Genesis probabilities for Oscar never got into the high category before the storm formed, and we think that the storm's tiny size may have played a role in some of that reasoning why the models didn't capture Genesis and why the forecasters had a hard time understanding if Genesis would occur as well. There were actually 2 periods where we were following Oscar's potential formation. First, well out over the Atlantic, over the Cabo Verde Islands. We had that system in the tropical weather outlook. It never formed there. And then we had a Genesis area as it approached parts of the northern Leeward Islands and north of Puerto Rico. But again, as I mentioned before, it never reached the high category. We just never got very confident that formation would actually occur. Another case was Hurricane Milton. surprisingly, even though the storm was so strong, Cat 5 over the southern Gulf, the short-term genesis probabilities were at 0% at the time that Milton formed. We did have high chance probabilities for the longer term 7-day outlook, but we never got into the high category, at least when formation occurred for Milton. So not only that genesis would occur, but you also might be able to see on these maps on the right that the star where Milton actually formed is on the far left side of the genesis areas that were predicted. So it's not just the timing of genesis, but also where the storm formed. It was just barely in some of those genesis areas, so we didn't really do very well in exactly where formation would occur. And again, remember, this was a major hurricane, so even with model signals of a storm possibly forming or a strong storm forming, you can still have some difficulties in forecasting when and where that genesis may actually occur. Okay, lastly, the last lesson that I kind of pulled out of last year is that something that we've been talking about for years now is that consistency is key. And what do I mean by that? Well, you can see there on your screen is the windshield wipers, and that is really what we're trying to avoid. When we put out a forecast, you see the cone of uncertainty. We don't want the forecast to wish-wash, windshield wipe back and forth from cycle to cycle, from forecast to forecast, because it really causes people to lose faith and trust in the forecast itself. So we do want to avoid the windshield wiper effect. And what I want you to take away from this chart here, or these two charts, is that, again, based on comparison to the models we use, we are showing more consistency from forecast to forecast than the models themselves. So what you're seeing on your screen here, on the left side is the Atlantic from last year. On the right side is the Pacific from last year. And we're actually looking at the 4-day forecast. So the forecast we would make for where the storm would be in 4 days. And the point here on this chart is that you're going to be on the far bottom left of these charts, which means you have low track error, or you're accurate. And it also means that you're high in consistency. In other words, your forecast is not waffling back and forth every time you put out a new forecast. And what you'll notice that from NHC, the black dot, it's as far to the lower left as possible. Whereas in the other colored dots, you have the European model in cyan, the UK Met model in that kind of pink magenta color, and then the GFS model in the dark blue. And you can see that all of those models are farther to the right on this image, which means that they're more inconsistent from cycle to cycle, and they're higher up, which means they're less accurate. And again, this is on the whole. So it doesn't mean that for one particular forecast or one particular storm, a single model might not still beat NHC, but if you took the season as an aggregate, NHC is ultimately beating the models in track accuracy, and we're remaining more consistent from forecast to forecast than the models. You know, here we like to say the models have no moral compass. They can bounce around from forecast to forecast and don't care. They don't care what they did 6 hours ago. We at the Hurricane Center do care what we did 6 hours ago, and applying that little bit of a braking system to those back and forth, those wafflings, does help us also to put more accuracy into the forecast as well. Okay, so those are my 6 lessons from last year. I'm going to take the last bit here to talk about some of the new things you can expect this year, and then I think we'll have some time to open it up for potential questions. So here is the list of some of the new products and services that you'll be seeing this year, and I'll try and go through a few of these here. Inland U.S. watches and warnings on the cone graphic. That's actually the second experimental year coming from last year. Updated issuance criteria for what we call potential tropical cyclones. There will be a new rip current risk map for the United States. We'll be introducing new size forecasts out through 60 and 72 hours. We'll touch a little bit on heat risk, and then cone size for 2025. So first off, looking at last year, I'm sure many of you have seen this, is that we debuted an experimental cone that includes a depiction of inland U.S. hurricane and tropical storm watches and warnings. And what this did is it better highlighted the risk of coastal and inland wind impacts. So not just focused on watches and warnings along the coast, but also what could occur inland. This product will again be experimental for this upcoming hurricane season. And really the only change you might notice is that on the legend, for cases where you have a simultaneous hurricane watch and tropical storm warning, you will notice that that has been indicated there in the legend. If you can see my cursor down here to the bottom, it's those areas that have an alternating blue and pink stripe. And I'll show you why here in a second we added that. If you took a look at some of the storms from last year, we noticed that it was actually a great year to debut this product because the new cone with the inland watches and warnings provided a better depiction of the inland wind risk from, for example, Helene in the southeastern United States. On the left side is the legacy cone, just showing the coastal watches and warnings. On the right side is an example of the experimental cone with the inland watches and warnings. And I think you can clearly see that that product showed how far inland the extent of hurricane and tropical storm conditions could have extended. And I should note, all of these watches and warnings that are issued inland come from the local WFOs. These are already watches and warnings that are issued for the storm. All we're really doing is providing another form of communication of those watches and warnings onto the cone product itself. Another example was Hurricane Milton. Again, on the left is the legacy cone with only the watches and warnings along the coast. On the right is including the inland watches and warnings. And I think you can clearly see that the experimental cone helped to highlight how far inland those hurricane impacts may occur, essentially across the entire peninsula, with the hurricane warning in red and the hurricane watch in pink. And then all of those impacts even extending farther south of where the cone actually covers the Florida peninsula. One of the things that we've highlighted here is that this new product provides less emphasis on the cone itself, while users are able to focus on the watches and warnings and actually understand their wind risk, despite what the cone may show. Because as we preached time and time again, the cone is not a risk product. It tells you nothing about the wind associated with the storm. You really have to focus on those watches and warnings. After last year, we did a little bit of focus groups, some surveys to get some feedback on the cone. This is actually from two of the conferences we attended last year. It was the National Hurricane Conference and the Florida Governor's Hurricane Conference. And we actually asked emergency managers and media at those conferences which of the two options would more clearly communicate overall wind risk. We had a sample size of 118 people, and clearly by a huge margin, you can see there was overwhelming support to provide this new product, with 96% at the National Hurricane Conference and remarkably 100% of participants at the Governor's Hurricane Conference saying that they would prefer the experimental cone with the inland watches and warnings. We also had an open comment period with public surveys from last year during the hurricane season so that people could provide real-time comments as they were watching these storms form to see how the product would work. We actually did a little bit of AI, manual human analysis of the comments. And just to show you some of what we got is that the positives were that people felt the new cone showed the true risk of wind in these areas, that the information is vital for decision making, and it does help reduce the emphasis on the cone itself. There were some recommendations for potential modifications, including a zoomable interface and more geographic references, both of things that we are working on as we speak. A little bit on the transparency or translucence of those layers. Again, we are looking at that as well. And then, as I mentioned a little while ago, some people wanted some explanation of what the hatching meant on the product. And so we did add that to the legend. Again, that's the simultaneous hurricane watch and tropical storm warning. So you will see that this coming year on the experimental product. Okay, potential tropical cyclone advisories. This is actually a service that we've been providing since 2017. This service allows us the ability to issue tropical storm and/or hurricane watches and warnings for systems that are not yet tropical cyclones, but have the potential to bring impacts to land areas within the next 48 hours. On the left is an example from a storm last year. It was potential tropical cyclone 18 that ended up becoming Hurricane Raphael toward the end of the hurricane season. And this particular storm, we initiated PTC advisories for areas in like Jamaica, the Cayman Islands, because we did expect land impacts in those areas within the next 48 hours, even though the storm had not yet formed. But one of the downstream impacts that you'll notice from the Raphael case is that we were able to provide information about the system in forecast form for what it might do even beyond Jamaica and the Cayman Islands. Cuba got some forecast information. Interests along the Gulf Coast got some forecast information. So there were some benefits, not just for those land areas, but even downstream to get this service. So what we have decided, and actually I'll get to that here in a second, since 2017, when we've used this system, it's actually given us an average of 21 hours of additional lead time on those watches and warnings by invoking this service. And in 2024, we actually invoked it 9 times. So 9 of the systems that we wrote advisories on started as potential tropical cyclone advisories. So what's the change for this year? Really, it's about extending that lead time from 48 hours to 72 hours, or 3 days. So beginning this year, we will have the option to issue PTC advisories when there is high confidence in significant wind and surge impacts within 72 hours of affecting land areas. And again, this is to provide enhanced services to significantly impacted U.S. areas. So for example, in Francine and Helene last year, U.S. was benefited from the system, even though the watches and warnings were for international areas to begin with. But now we won't have to be limited by that necessity. We'll be able to issue these advisories whenever we expect significant impacts within 72 hours. The key thing here to note is that it's not tied solely to watches and warnings. So there could be cases where we expect impacts within 72 hours. We'll issue PTC advisories, but the watches and warnings still will not be issued until we get within that 36 and 48 hour time frame. So you could see forecasts for a system with no watches and warnings. Again, it's just to get the forecast information out there sooner, and then the products that would go with that. For example, wind speed probabilities, storm surge probabilities, peak storm surge graphic, and the like. Those can all be issued once the PTC advisory has been initiated. Okay, something else new to expect this year is that we have produced a rip current risk viewer for the United States. One thing I'll note here is that rip currents and heavy surf, if you go back to the pie charts I showed at the beginning of this talk, they are actually the 3rd highest cause of direct U.S. fatalities from tropical cyclones when you look at data from 2013 to 2023. So think about that a second. We've talked about the water impacts. Well, the rip currents and heavy surf that occur along the coast is the 3rd highest cause, or 16% of these deaths. So we know we need to get more information out there about the rip current risk for these storms, even if they're not making a direct landfall. Many of these rip current deaths occur from hurricanes that are well offshore, so the communication can often be a little bit more difficult. But we will be providing this map viewer this year during active tropical cyclones. So that's important because this map will not always be available 365 days a year. It will be available whenever there is an active tropical cyclone in our area of responsibility. And really all we're doing is just recommunicating what's already being produced by the local National Weather Service forecast offices, including Puerto Rico, along the East Coast, the Gulf Coast, and even for portions of Southern California. So it's just going to be an easier way for people to access that information, again, when there is a tropical cyclone. But the service itself isn't new. It's still being provided by the WFOs. We're just providing another way to visualize and see that data when there are active tropical cyclones. Okay, size forecasts. So if you're not aware, the way we do size forecasting is by providing wind radii forecasts. In other words, how far out from the center do different wind thresholds extend? And simply what we're doing here is that for 60 and 72 hours, we will now be providing hurricane force wind radii out that far. Prior to this year, we only provided hurricane force wind radii out through 48 hours. So this year, it'll also be out through 72 hours. Kind of a footnote here for some of our more sophisticated marine users is that for years we have provided 12-foot seas. In other words, how far out do the seas 12 feet high extend from the center? And based on the high seas forecasts that are being produced by the National Weather Service, that is being converted to 4-meter seas to serve the international marine community. So again, just a little bit of a footnote there so that you are aware of that slight change. Okay, it's not just about hazards that occur during a storm, but we're also concerned about hazards after a storm. So as we all know, sometimes we can lose power during hurricanes because of the wind, and sometimes heat waves set in after hurricanes. And when you don't have power and a heat wave sets in, it can be very uncomfortable. In fact, it can be even deadly. So we have been working with the Weather Prediction Center to begin providing highlighted areas that are at risk of heat impacts after a storm due to power loss from wind impacts, and then when we do think there is the risk of heat impacts as well. So some of the considerations that we may look at, or that WPC may look at, is the chance of strong damaging winds. We can use that as a proxy for power loss. And then those areas that occur simultaneously or on top of areas that have those risk of heat-related impacts over the ensuing days. And as you may be aware, WPC, the Weather Service, unveiled a new NWS heat risk product, as you can see there on the left part of your screen, that can be used to help assess what the heat risk may be after an event. So when appropriate, be on the lookout for this messaging, which may occur in our public advisory and then also in the key messages we put out. So it won't be available for every storm, but when NHC and WPC think that the heat risk is significant enough, you will probably notice these messages being incorporated into our products. And lastly, just to quickly touch on the cone of uncertainty, and I'll preface this with, again, the big asterisk that the cone says nothing about the impacts of a storm. It's just where the center of the storm may travel. But that being said, I know many people are often interested in what does the cone look like for this upcoming hurricane season. And what you'll notice there is for the Atlantic in the center column and the Eastern Pacific on the right column is the cone, essentially the radii for the cone at each of those forecast times. And in parentheses is how it has changed from last year. So for example, if you look at 120 hours, the Atlantic cone is actually 3% smaller at day 5 in the Atlantic and 4% smaller in the Eastern Pacific. For the most part, the cone has shrunk slightly at pretty much every forecast time. I think the only time that you won't see a change is 12 hours, and even there it's pretty imperceptible anyway. So just slightly smaller this upcoming year, but again, that just makes the impacts of hazards occurring outside the cone even more profound, since we know the size of storms themselves are not changing. Lastly, I'm just going to end with the names, just to give you a preview, if you hadn't looked already, what to expect for this year's tropical cyclone names for the Atlantic. You can see there on your screen, started with Andrea, Barry, Chantal. I'll just note that we have a newcomer this year with Dexter on the list. That was the replacement for Dorian, which occurred in 2019. So you can get a grasp there of the names for the Atlantic. For the Pacific, I don't think we have any newcomers there, but you can see the first few names for the Pacific would be Aletta, Bud, Carlotta, and so forth. And then lastly, for anybody watching or interested in the Central Pacific, names out there are a little bit different. There's a kind of a continuous lists that are used. The last name that was used last year on the Central Pacific was Hone. So the next name on the list, if there is a Central Pacific cyclone, will be Iona for this upcoming hurricane season. So those are the names for next year. And with that, that's pretty much all I have. If you have questions and comments, I'm sure we can take a few here. And then if you have any comments or questions afterward, there's my contact, and I can try and answer them there as well. So Catherine and Alyssa, I'll turn it back to you guys for Q&A.
Amazing. Thank you so much, Robbie. We did get some folks thanking you for this presentation in the chat, so I will say that. Been trying to pull out some of the more frequent questions we've got. One of the first ones was when you shared the statistics for some of those injuries and fatalities and even some of that economic damage. Could you speak a little more to how the Hurricane Center gathers those statistics, especially for states?
Sure, yeah. So our go-to source for the United States is to go through NCEI, or the National Centers for Environmental Information, which is actually located in Asheville, North Carolina. They're the gurus when it comes to kind of gathering all that type of information. For the cost, I should mention, that's for the cost of kind of damage and that those storms have caused in the U.S. Fatalities, what we try to do is get direct information from the states, from medical examiners, et cetera, to try and compile that information. It's actually not an easy process because, as you can imagine, that information is disseminated in different ways in different states, different counties. And so you're kind of like a sleuth or detective just trying to piece together all the information you can get. We rely on media reports too, especially in international areas. The countries across the region will provide some information to us as well. I think the long story there, or sorry, the short story there is that the information comes from a whole bunch of sources, and then we're just trying to compile that the best way we can. I think like anything else that we do, there's probably a plus or minus of a few percentage points there because we can never know exactly how many fatalities have occurred, but we do try to do our best to compile that as best we can.
That makes sense. One of the next questions was, you mentioned that sometimes, especially in these rapidly intensifying hurricanes, that the model sometimes doesn't pick that up, and that's something that forecasters see. So the question was, what skill are these forecasters applying when the model isn't picking up some of these rapidly intensifying hurricanes?
Yeah, I think one of the key things is that some of these models don't really know a whole lot about the structure of these storms just before they go through rapid intensification. The specialists here have gotten really good as when we get something that's called microwave data. So in other words, it's a satellite looking down back at the Earth, and that particular type of satellite data allows us to peer inside the storm itself. It gives us an understanding of kind of what the structure of the storm is like. And we've started to understand patterns based on that microwave data of storms that look like they're about ready to go through rapid intensification. They start developing signatures where you'll see a low-level eye wall start to form, things like that. And you have to compound that with, well, what's the environment like? I mean, is it over warm waters? Is the shear low enough that could support that type of intensification? And I think that the human forecaster is able to see some of these signals that, at least right now, some of the models aren't yet picking up on. And that's why we're seeing a slightly higher rate of detection for some of these events. But as I showed in that chart, the false alarm ratio isn't really that much different. So there are still cases where we think RI might occur, we're forecasting it, and then it doesn't happen. That still does occur on occasion.
That makes sense. Let's see, you answered that question. Oh, we got some questions about the U.S. rip current risk map. Could you tell us again where we could find that information?
Yeah, so on hurricanes.gov, if you're familiar with our webpage, when there is an active tropical cyclone, those cyclones are usually grouped into boxes where there's a bunch of thumbnails and forecast products for that particular tropical cyclone. It will be another thumbnail in that box when there is an active storm. So it's not that there's going to be a link somewhere where you can even go to it now. It will only be active when there is a tropical cyclone in our area of responsibility.
That's good to know. And let's see, we'll do one more question, just recognizing time. We are finishing up here in about 2 minutes. So let's see, we've got some questions about the hurricane season outlook. Do you guys at the NHC have an expected date when that will be released for this year?
Yeah, right now NOAA is expecting to release that sometime in mid to late May, which is typical. So I don't have an exact date for you at this moment, but it will be about mid to late May.
Okay, perfect. And with that, Robbie has his email up on the screen. You can also reach out to our SECART email if you have any follow-up questions that we were unable to get to today. I did want to share real quick um, the next upcoming webinars that we have, and we will post that link to that website where you can register for these webinars in the chat. Our next one is May 8th, and that one will be all in Spanish. It will be very similar to the presentation that Robbie shared today, but with fellow Weather Service colleague Crizia Negron, who will be sharing this presentation in Spanish. So we will also be posting this webinar on SECART's YouTube page for folks that may have joined a little late, or if you want to share today's presentation with your colleagues. So with that, thank you again, Robbie, so much for today. We really appreciate you being here, and we really appreciate all you folks that were able to join the call today. So thank you so much.